So now, witness the wrath of the man.
It's simple mathematics. Check it out.
What is up, AP Calc class? This is yo boy Devin Ramsden bringing you the truth on the TI Inspire with Joe Farice. And today we're going to be looking at limits on this little installment. So, come on in, let's dive right into it. So, we're going to go to our symbols, and I do not have a CAS TI Inspire, but if I did, I'm going to show the people out there that do have it just how easy finding limits can be. So yeah, so we're gonna go X. Let's go to 2. Alright. And then we're gonna go square root X plus 2. Why not minus 2? And since I like 2's today, X minus 2. Now, if I had a TI Inspire CAS and I hit enter right now, it would give me the answer. But since I don't, I'll just show you what happens. It says unsupported function. This function requires computer algebra system TI Inspire CAS. So I don't have that. So all of you that have that, well, I'm jealous. But you still have a great calculator in front of you. So what we're gonna do? Oh shoot, we're gonna delete this, and we're gonna just store a function, the same function I put in. Store as, h of x. I'm feeling spontaneous today, so just gonna say done. So, just for those who don't know, you can do a lot of things with this. You can be like, all right, 77, what is this? Gets you that answer. You can also actually use the control set equal to store a function, but I just like store better. Okay, so what can we do with this to approximate a function? Also use the set equal in place of the store, but I just like store better, so it'd be control set equal to. So what can we do with this, especially approximating a limit? It's kind of like what, but with this beautiful calculator you can do a lot. So we're going to go to lists and spreadsheets, and we are instead of typing all my function values in, I'm going to be a little lazy, but I'm going to teach you something. It's called sequence, and it's just, you can put SEQ just like that, and then you can kind of cheat and have the calculator do work for you. So what we want to do, we want to approach our limit as approaches 2 from both sides. So I'm going to put it in parentheses. I'm going to go sequence 2 plus 0.01. I'm going to say t. And then I'm going to make sure they know that t is a variable. Then you're going to go from -5 to 5 on t. So you hit enter, and basically what's happening, it's going from, this is 5, 4, 3, 2, 1, and then you got, then you got 2, when t equals 0, and then you got negative 5, -4, -3, -2, and -1. So you got that, and that's a little tidbit how you can kind of cheat. And then over here, you want, now there's a little bit of funky notation in what I'm going to be doing next, so pay close attention. So what we're going to be doing is going to be h of a, and that's there because you want everything in column A, right? And then you need the brackets. That's for notation. It's kind of funky, but that's what you got to do. You're going to hit enter, and you're going to get these y values per se. So what we find, so it's so you're going to find it, and you can see as it approaches 2, you're getting pretty close to what? That's right, 1/4, as you can tell. So it's getting pretty close to 1/4, but not actually ever getting there. And so, right, you can approximate this as x gets closer and closer to 2, but is slightly more than 2. So as x gets closer and closer to 2, but is slightly bigger than 2, um, it's approaching what? So as x gets closer and closer to 2 and is slightly bigger than 2, it's close to 1/4. And as x is closer and closer to 2 and is slightly less than 2, it's close to 1/4. So from there, you could probably draw a conclusion. However, you can, just by changing your sequence, you can make it a little more finite. So if I add a couple zeros, yes, override the thing. So from now, it's pretty easy to tell that your limit's going to be 1/4. And that is how you approximate a limit on the TI Inspire. I hope you keep watching our vids, Much love. What is up, AP Calc class? You're here with your boy Devin Ramsden, as always, bringing you the truth on the showdown of the TI Inspire. So, on the third installment of the little mathematical journey, we're going to be looking at local extrema. And, yeah, but first, I want to show you guys, if you didn't know, there's a catalog right here. And it's really in-depth. They really did a good job on it. And just anything from, like, knowing what symbols are to being able to write correct notation for a lot of the advanced and new kind of notation that you're used to from the old TI 84s. And it even has like chi-squared stuff that you wouldn't even need in calculus and like all this wacky stuff, summations. But anyway, if you don't know that was there, that is there. So I'll get out of that. And we're going to go to the graphing portion of the TI Inspire. We're going to enter x squared, something simple. I'm keeping it simple on you guys. So there you go, beautiful parabola right there, as you see. And I'm gonna find out, where's the minimum? I don't know. So you go into analyze graph, or menu, analyze graph, and then we're gonna go into minimum. So it's a lot simpler than the TI-84, what it used to be. So you can put a window. So like, for instance, if you want local, you can set up like boundary type things, and it gives you it. It's really cool. And obviously our minimum was at 0, 0. And so, yeah, that's that. It's pretty simple. What is up? How you doing? Hello, AP Calc class. This little tidbit is for all my physics fanatics out there who are frustrated with having to switch from degrees to radians and not really knowing how, because there's a lot of buttons on the TI Inspire, and it's confusing, So you want to go into settings, right there. Yeah. All right, go into document settings. And there you got angle, and right now it's in radians because I just was in my calc class. And say you want to go to degree, you just click it, and then make sure you hit enter, apply your settings, and save them as default for new documents in Scratchpad. Oh yeah, sure, why not? And hit OK. So now, if we go and you're like the sine of 90. It should be 1, and that's right. But if you put in radian type stuff, so if I say the sine of pi divided by 2, guess what? You're not going to get the correct answer because it's in degree mode. And that's important because, if you do that wrong on a test, you're going to get punched in the face, probably. And then you're going to be looking at your test and be like, man, I know this stuff. And then you're going to realize it's going to hit you like a ton of bricks that you didn't have it in the right mode. So always make sure you're in the right mode in what class you're in. The teacher will probably say it, but yeah, thank you. Well, what is up, AP Calc class? You're here with the 4th installment of the TI Inspire Showdown, and I'm going to be showing you a little bit of stuff about integration. A subject that, is always near and dear to me. All right, let's get back into it. All right, so we can do this 2 ways. The fast way, in my opinion, is just to go to symbols, and if you get good at it, you can just click this, gives you the integrand, and boom, you got the weird-ass looking thing as always, and then you got A, B, A, B. You got your function in here, and then you got your variable in here. So there's that. So basically, what you can do is, I remember doing this on the TI-84s. It took like forever, and now it's just so easy. The other way you can do it is go to Menu, Calculus, Numerical Integral, and it gives you the same thing. So let's actually do something. So let's go with cosine parentheses x. I'm going to go from 0 to 0.5 and x. And that is your answer. So it's really fast and very convenient. But you can also do this another way, graphic kind of way. You can go to your graphic parts. You can enter cosine x. Alright, make sure you got the parentheses or else it won't read it as a function. There you go. Hit enter. And you got this beautiful, nice colored graph. Next, you're going to go to menu. And usually if you want to do something to the graph or want to gain information, you hit analyze graph. And you, as you see, it gives you a bunch of cool stuff. But what we're looking for is integral right here. And as you know, the integral is really, all it is really the area under the function. And so you can go like this, and it gives you, look at that, it gives you shaded in and stuff, and it's really cool. So that is not really at 0.5, but you know, it's close and you see the point. So your answer would be 0.588. And that is how you twerk the integral on the TI Inspire. I hope you enjoyed. What is up, AB Calc class? We're here for the second installment of the TI Inspire Showdown. So we're going to be looking at differentiation, pretty simply put on the TI Inspire. So you're going to go into menu, calculus, numerical derivative at a point. So x, you're going to make the value anything really, but we're going to say 2. And we're going to only go to the first derivative, although it does also do the second derivative. If you hit this arrow right there and hit OK. So dy dx or ddx, whatever. And we're going to make the function x squared. Okay. And so you hit enter, and it is 4. And just to look at it a different way, we know the derivative of x squared to be what? 2x. And as you know, 2 times 2 does in fact equal 4. So we know we're correct in that. So another way you could look at it, and it's pretty cool on the Inspire, you can go from a graphical point of view. So if we plug in the function x squared in our y equals, you get that beautiful parabola, and you can do a lot, and you're going to say actions, or no, analyze, sorry. You know, dy dx. And then you can choose any x value just by scrolling your cursor or mouse, and it'll get you the derivative at that point, which is a pretty amazing thing. So say I went there, the derivative is negative 3.9. As you see, the slope is this way. It's a pretty cool little tidbit that the developers added. And yeah, so next, now say you want the derivative equation. We're back here, and you can go to menu, go to calculus, and numerical. Okay, never mind. What is up, AP Calc class? My name is Devin Ramsden, bringing you the truth on the TI Inspire. Today we're going to be looking at a cool feature of the TI Inspire called 3D Solids of Revolution. And what we got here, we got a sine function, and it's modeled on the right as a 3D graph, which is pretty cool. And you can move so that as C changes, you see it on the other graph as well. So I'm going to try to explain this as best I can. It's pretty complicated though, so let us go. Alright, so first we're going to learn how to split up the screen like that.
because I didn't know how to do that. So